Hello. Today I'm going to talk about applying time value of money principles to solving life insurance pricing problems. So, this very specifically talks about or refers to how do you put a value on a life insurance policy meeting certain criteria. And we'll solve some very simple cases to give you an example, to give you an idea of how to approach these kind of problems, right? And they're fairly straightforward applications of time value of money or present value of annuity, future value of annuity, present value of single sums, and future value of single sums that we've already discussed in other videos. So, that said, let's start by looking at a mortality table, which is the bedrock of all life insurance or insurance type problems involving mortality issues. And every insurance company has their own in-house mortality table that either they develop themselves and fine tune over time with lots of statisticians and lots of people trained mathematically to look at these things and to tweak the numbers with new data as they become available. So in this particular example, this is a mortality table for men born in the 80s, and then you have ages on the first column showing from 35, 36, 37, 38, 39. And then the next column is number of people living. Then third one is number dying. Then percentage of death and percentage of living. So those are the five columns. Now, just to give you a better understanding of what these numbers are telling us, so on the first row, you see the number of starting sample of 35, age 35 male in this mortality table is 949,171. And then the number that's expected to die between 35 and 36 is given as 2003. Then between 36 and 37, 2,121 men are expected to die. Then between 37 and 38, 2268 men are expected to die. 38 and 39, the number is 2432. Finally, between 39 and 40, 2,623 people are expected to die. So now if you take the number in column 3 and divide by the number in column 2, you get the corresponding fourth column numbers. So 2003 divided by 949,171 will give you column 4 numbers correspondingly, and then 1 minus the value in the column 4 will give you column 5. So that's basically where we are. And this is what we are going to use to solve our problems that I'll be discussing shortly. We'll come back to the numbers in this table. So now, here's the boilerplate on how we compute or go about thinking about computing premiums, life insurance premiums. What we do is step one is we calculate expected claims. So and we make a simple assumption here for the purpose of the problem is that all people who are dying between the ages of 35 and 36, for example, the payoff will occur for them at 36. Then for people dying between 36 and 37, the payoff will occur at 37. So at the end of that corresponding period, in other words. Now, does that make a big difference whether the payoff was instantaneous at death or versus waiting till the end of that period? Really not. But it makes explanation of what's going on much more simple, doesn't complicate matters, and it won't change any of the stuff that we're discussing in any material way. And therefore, for simplicity, I just use that simple assumption to make my point. And so what we calculate is expected claims of the percentage death times the face value of the policy, right? And that will give you the expected claims at each of years 36 for people dying between ages 35 and 36. Then again, expected claims at 37 for people dying between 36 and 37, and so on for the next 3 years. Now, once we have those expected claims occurring at each of those time periods, 36, 37, 38, 39, and 40, the next step is to find the present value of those sums of money that occur at those points in time. And all we are doing at that point is using the single sum equation that you've seen many times before and just simply discounting them appropriately back to the starting point, which is 35 in this case. Understand that this is a term life policy, which means that your beneficiaries get paid the face value of the policy only if you happen to die while the policy is in force. Otherwise, there is no payoff. You simply pay the premium, you get covered, but there's no payoff, right? So, keeping that in mind, you then come up with the present value, which is of these individual sums that occur, expected claims at each of those time periods of 36 through 40. And then once we present value those amounts back to 35, which is the starting point in our example, it can be any other point in time. It doesn't matter. For the purposes of this discussion, the starting point is 35. And therefore, once we have discounted everything back to the starting point, which is 30 age 35, then we simply add them up. And that's the present value of those sums summed up at 35 represents our present value of the claims, i.e., the price of the policy with that face value. Now, notice the assumptions we made. One is, of course, that the payoffs will occur at the end of the respective time periods of 36, 37 through 40. And the other is, of course, for simplicity, we assume that all of them will have the same payoff. All of the policies here have the same payoff, face value, in other words. That doesn't have to be the case, but those minor changes will simply complicate the discussion without changing anything else. So therefore, we just, for simplicity, use those assumptions. Now, and also keep in mind that it is perfectly kosher to sum up money at the same point in time, which is exactly what I did here. And keep in mind that insurance claims are a little different than other claims in the sense that the premium has to be paid right away for the policy to start. So the payment occurs at the starting point rather than the end of the period for the policy to become in effect. That has some implications when you're discounting future cash flows back to the present, as we'll see in a concrete example.